All right. Good morning. Hopefully, you guys are doing well. I'm just going to answer questions from either your packet, your notes packet, or the test review packet. Let me know if you have any questions or if there's any particular problems you want me to go over. Okay, we can go over one of those problems. Let me find it. Morning. Okay, give me 1 second. Yeah, let's see. Okay, so here's a good one. This is on page 44, number 5. '44 in your notes packet. Okay, so it says the function has a derivative for all orders for all real numbers. The fourth derivative of x equals e to the cosine of x. If the third degree Taylor polynomial for f about x equals 0 is used to approximate f on the interval, what is Lagrange error bound? So we're trying to find the third degree remainder for this Taylor polynomial. So let's just set everything up and then we can fill in the gaps. So I want to find the third degree. Well, let me write out the full formula and then we can fill in all the variables. Okay, so we're trying to find a third degree Taylor polynomial or a third degree error bound, so that's our n value. So our n equals 3. About x equals 0, so that's our c value. On the interval from 0 to 1, so 0 is c, and 1 must be x. Okay, so I want to find r sub n of x, replace n with 3. My max, I want to find the max of f of n plus 1, so that's going to be z here, sorry, over 4 factorial, 1 minus 0 to the 4th. Okay. So we want to maximize the 4th derivative. Well, we know what the 4th derivative is, so we just have to maximize this value. And what I mean by maximize is we have to decide between 0 and 1, which is going to produce the larger value for this. We're going to insert 0 and 1 in for x and see which one will produce a larger value. So we want to compare e to the cosine of 0 versus e to the cosine of 1. See which one is larger. And that's, well, the nice thing is that, I mean, there are other values between 0 and 1, but on the AP exam, if you're having to decide which one has a larger value, you only have to worry about the endpoints. The graph, well, this data will always, with this graph will always just either increase or decrease. So there's not going to be any hidden max that is between your endpoints. So you just have to test your endpoints. So we'll plug this in the calculator, see which one is larger, and whichever is larger will go in this space. So e to the cosine of 0, that's e to the 1. You plug in the calculator, e to the first power is 2.72. And e to the cosine of 1 is 1.716. Okay, so e to the cosine of 0 is going to produce the larger value, so which is e to the first power. So we're going to insert this into the max value. Now, sometimes Lagrange error bound has very explicit definitions for how to get the max value. So there are times when you don't have to even worry about testing between x and c. Sometimes they tell you exactly what that relationship is. So on the test review, page 16. Oh, all right, page same page, sorry, number 5, page 44. Number 4, you see how the nth derivative of x is always less than or equal to n or n times n plus 1. So in this case, we can just follow whatever the rule says. So the maximum is going to be whatever that n value is, the n plus first derivative, we can just plug that in 4 over 4 plus 1, which is 4/5 in this case. So sometimes you have to play with it, test endpoints. Other times, if the definition is just given to you, you just follow that definition. Okay, does that make sense? Okay. Any other questions you want me to, any other problems you want me to work through with you? Okay, the reason why for this problem, why the n is 4 and not 5, because um, it's asking for the third degree remainder, because it's giving us the Taylor polynomial of the third degree. So the difference between that and the actual function is going to be at the third degree level. So we're asking for the remainder at the third degree. So if the remainder is at the third degree, then we want the max of the n plus first derivative. So we want the fourth derivative. So that's why it's 4/5. Because we're at the third level here.
Jay, for something like number 9 on page 7 of like the worksheets they had to do,
Okay, sorry, which
page 7.
page 7 on the test review?
Yeah, like
Mhm.
number 9. Is there a reason why you can't just do like 1 plus x squared over 2? Et cetera, is it because it's centered around x equals 2?
Yeah, centered at x equals 2, which means that the derivative may get thrown off with that 2. Yeah.
So you plug into like.
Yeah, we have to plug in 2 into the fourth derivative to get that c cleaned up. We want to find the fourth derivative evaluated at the center at 2.
In order to find both things, you plug it into for every single x.
That's right. Yeah, you would do f of 2 plus f prime of 2, parentheses x minus 2. Yeah, yeah. This was page 7 from page 7, number 9. That was what the question was about. Okay, you want to do a interval of convergence question? All right, CJ. Let's see. Okay, all the interval convergence prop variety are on page 16 in your notes packet. So, you have ones where the the ends go away, and if they go away, you can just focus on your interval of conversions, and it's going to be x minus c is less than r, and we got to test the endpoints. But if the ends get in the way where the ends end up pushing or remains in the problem and pushes it out to infinity, then the series will only converge at the center, meaning that it diverges everywhere else, but we can at least guarantee that the center will converge. And then if there's ends remaining in your after you do your ratio test, but n is in the denominator, then that's always going to force your limit to be 0. And if you force your limit to be 0, that's always less than 1, which means that this will always be true. No matter what the x value is, my n is always going to push it to 0. And so in that case, my radius of convergence is infinity, and my my interval convergence is all real numbers. Nothing will cause, no x value will cause my limit to be greater than 1, because that n is always going to cause any x to approach 0. Well, because n is approaching infinity, that denominator increasing will always force whatever fractional value to go to 0. Okay, so those are the all the possibilities. So if you want me to do a specific type of problem, let me know. I'm looking at page 15 through 18, 15 through 20 on the notes packet. Okay, we got to test the values. Yeah, let me just pick one of these. We can do that. This is page 20 of the notes packet, by the way. All right, so we want to find interval conversions. We got to go through ratio tests, so we'll do that. We'll do the n plus first term. Divided by the a sub n, which is something that's multiplied by the reciprocal. Oops, sorry. I need to add 1 to n, so this is n plus 2 here. This is n plus 1. Okay, let's clean this up here. I'm going to group all the x's together and group all the n's together here. So All right, so let's see what happens with the ends. Well, the nice thing is that I think all the ends goes away because ln n and ln n plus 1, that's the same degree. And then n and n plus 1, that's the same degree as well. So everything matches up nicely. The coefficient is just 1, so this just kind of goes away. Let's look at the x's here. This can cancel out. I can cancel out one of the x minus 2's. So that's nice. I'm just left with absolute value of x minus 2 is less than 1. So center is 2, my radius is 1. I'm going to do my interval convergence. Add 2 to both sides here. All right, so we know our interval convergence is at least this, and we have to test the endpoints. So the way we test endpoints is we plug 1 and 3 into the original, okay, in for the x's, and then see what we can do with that. So test endpoints. I'll test x equals 1 first. So 1 in for x. All right, so negative 1 to the n plus 1 all over n ln of n. This is an alternating series, and the only thing that requires for an alternating series to converge is if the rule of sequence without the alternator approaches 0. So we know that for sure. Limit as n approaches infinity of 1 over n ln of n guarantees to approach 0 because there's nothing in the numerator, and that denominator is getting larger and larger. So we know that this converges. Okay, test x equals 3. So now I'm going to insert 3 in for x. So 3 minus 2 is 1. Hey, I just have students online who are asking for help, but you can, if you have any questions. All right, so this, we really don't know if this converges or not. This is not an nth term test is not going to help us determine if this converges. And if we look at this here, it doesn't really fit any of the rules nicely, but I think it does fit the integral test because it looks like this could be a use substitution problem. So if I can prove whether this converge or diverge, then I can decide what's happening with this rule of sequence. Okay, use substitution, my u value is natural log of x. Okay, 1 over u du is just natural log absolute value of u. evaluate between 3 and b. So we evaluate the upper and lower bound, natural log of b minus natural log of 3. And if I replace b with infinity, this is going out to infinity. This is going to diverge. So integral test. Hey,
It passes the yellow ones. I ran out.
oh,
Oh,
here we go.
perfect.
Mhm.
Oh, thank you.
Yeah, sure. So we know that we're going to diverge at x equals 3 because the endpoint is not going to allow for the conversion, but the 1 does converge. So our interval of convergence, we can include 1, but we can leave out 3. So here's my interval of convergence.
I have a question. In the second half of the unit, are there any initial conditions or like things that need to state before you do the problem? Because I just remember looking on the answer key for the test review, and you just put the absolute value of the s minus s of k is like less than or equal to the absolute value of a to the n plus 1. So for the errors, is that necessary to put, or are you just trying to explain that?
Yeah, I'm just trying to explain that it's an alternating series error bound that we're applying. But no, you don't have to necessarily state it unless it's asking for justification. Then your justification is that the first unused term is going to be the error bound for an alternating series, for a converging alternating series. First unused term.
Alternating series.
That's just for alternating series. Yeah, if it's not an alternating series, if it is like a Taylor series that's not alternating, then the best we can do is to use Lagrange error bound, which is messier, right?
Thank you.
Mm-hmm. Okay, so which testing rules do we need to know? You need to know all the ones that you've been tested on the quiz. So nth term, GST, comparison test, E series. Yeah, those are the main ones. Or I think limit comparison test is enough. Hey.
I haven't seen you at one of these in a while.
Yeah.
What's it been like? 12 hours?
Huh? They've just been asking questions about interval of convergence. How to find the max of Lagrange error bound. We did an interval of convergence problem.
So the max, wait, it was max error bound for something like e to the x. That's just where you just plug in whatever your x is. Because most likely the center is going to be 0. I don't
Yeah.
think we've had one where the center wasn't 0 for
Right, yeah, it's always been 0 and something else. So yeah, you plug in 0, you plug in your center and your X value, whichever is a larger value, that will be your max. Unless there's an explicit definition for how to find the max, then you just use that definition and you just plug
Like
that
that one
value.
problem that was like f to n was,
N over n plus 1.
Yeah.
Yeah. If the definition is given or a table is given or something where it's explicit, then you just use that.
well, when it's that one, it's just gonna be n plus 1.
Right.
I'm gonna make sure I have like the convergence, not like test, but like at the end of the thing. So for n term, when it's not 0, it's divergent, and if it equals 0, it's inconclusive. For geometric series, it has to be less than 1, like the R has to be less than 1. For the P series, the P has to be greater than 1.
Yeah.
For ratio, if it's greater than 1, it converges. If it's less than 1, it diverges.
For
Ratio.
comparison test. Oh, for ratio test.
Ratio test.
Ratio test, if the absolute value of the expression is less than 1, then it converges. If it's greater than 1, it diverges. If it's equal to 1, it's inconclusive.
Why not less than? Yeah, so if it's less than 1, it converges.
Converges.
If it's greater than 1, it diverges, and if it equals 1, it's what?
If it's equal to 1, it's inconclusive.
How did you get inconclusive?
Right, but typically you can look at a series and know that it's going to be a ratio test.
For root test, that's just, isn't that finite number?
Root test is if your expression can be taken as the nth root, then you just take, like, for instance, if my series is like something like that.
Then after you do.
Let's say this is 2.
After you do
the nth root.
Is it just nth term test?
Then it's just like the ratio test.
Oh, right.
Which is less than 1, and that will converge.
Okay.
So it's the same conditions as ratio test.
And then, but limit comparison test is a finite number, correct?
That's right. Limit comparison test is a finite number. It's a limit of the comparison partner with the rule of sequence, and then you just divide them over each other. Doesn't matter which order you divide them. And if you get a finite number, then you know that both of those series will share the same converging or diverging behavior.
DCT, it's if it's greater than and it converges, then or if it's greater than and it diverges, then it diverges. If it's less than and converges, then it converges. Okay. Then integral test, it just has to be greater than 1.
Integral test, it just has to be a real number.
All different.
That's a real number, yeah. And the condition for integral test is positive, continuous, and decreasing sequence.
I'll see you in a second.
Yeah, see you in a second.
Definitely wanted to ask. Talk about that. Can you go up on the paper outside? The question that you had up above it.
Yeah, so but we did number 20 here. This is page 20 in the notes packet.
Big one?
Yeah, big one. We did a full interval of convergence where we had to test the endpoints.
This is a lot of crossing out ones. Can you just can you just say, like, the center is always going to be what the x minus in parentheses is, correct? So, and it's always going to be like less than 1. So unless there's like a number on the bottom,
right,
just assume that the center is going to be 1 and that the rate, or that the center is going to be whatever the c value is, and the radius is going to be 1.
Right. Yeah. So just watch out for any leftover coefficients. If there are any leftover coefficients, I'll make sure you bring it over, and that's going to be your new radius.
So like the only we probably need to show all the work on this just in case we mess up. But I'm saying, like, in this case, since there's no number on the bottom, or any number anywhere else, it's just gonna be x minus 2 is less than 1.
Mhm, mhm.
Okay.
And then we know our potential interval convergence is between 1 and 3. So we're going to test 1 and test 3. 1 will just be AST.
Struggling for so long figuring out like the -1 to the n times 1 to the n, and like,
Mm-hmm.
because I forgot like the bases need to be the same for the variables to have.
Oh, right, yeah. And then so 1 is 1 passes easily, but 3, it's no longer a alternating series. So we're just left with 1 over n times ln of n, and that doesn't quite fit into any of the easy convergence tests, but U substitution can handle this problem, so we go through integral test. Integral test gives us diverging, so we're not going to include 3 in our interval.
I feel like I'm just here because I'm scared, because like I didn't do well on the first 2 quizzes of the unit. So I feel like I just needed to come to make sure. Because
Yeah.
some of them, I know how to do like almost every question. That isn't the issue. Like that's not the issue. It's just sometimes I stare at it and don't know
Where to start, yeah.
I think the places I get more confused are when it asks for like the first 4 non-zero terms. And then I like sometimes I just do that. I do those ones.
Okay.
The general terms is probably gonna be the thing I mess up on this. If anything.
Yeah, but usually if it's asking for a general term, it's usually building it from a known general term, from a parent general term.
So they'll either give you the function of like a cosine where you have to know what the general term is, or they'll give you the general term. You've been okay.
Yeah. That'll be the pattern.
Be wild if they just made you free ball it.
Yeah, that's
Could they do that? Because like if they give you the function of like not one that's like, well, I guess they'd have to give you the function. They either have to give you the general
they
term.
could, but it's doubtful. And also, if they do that on the AP exam, then you know that they're not going to put a whole lot of points with that one. I wouldn't spend 10 minutes trying to figure that out when there's other things you can be working on. Yeah, it's not worth the effort.
On the question that we don't have to pull up because it's not one that I need to see worked out, but like the one where you're looking at like which of the following must be true. Because there was the 2 scenarios with that one.
Mm-hmm.
Would you like lose points if you didn't show the other scenario? Like if you just assumed that 7 was the endpoint, so that 1 was the other endpoint? Like, or you know what I mean?
No, you wouldn't, but it just gives us just further peace of mind that all the scenarios are taken care of and that we are making the proper conclusion.
Because I got down wrong. I said 2 and 3 were true because the series diverges at x equals 0. Because I said that 1 was the endpoint, but it doesn't have to be true for the other scenarios.
Right.
If I were to get that wrong, I wouldn't get partial credit if I didn't show the other scenario. If I showed the other scenario and still somehow got it wrong, or that.
I think I would give you partial credit just because you understood at least one scenario and how to build the interval of convergence from that one scenario. This one here, right?
I just assumed that there was only the first scenario.
Well, the second scenario, we can say that
The radius.
right, because you're looking at this saying, well, I mean, if it diverges at 8, then I don't have to go this far with this one. But this one is a stronger, this allows us to see things from a different perspective, because if it diverges at 8, it's possible that the radius is only 3, but also possible if it diverges at 8, that we could extend that radius all the way to 4. So that just gives us some additional data to compare with. Yeah, so I meant to say that this one, scenario 1, passes in terms of that it does that. I wrote it out a little differently.
So there was a question on here that was, what is the radius of the convergence? But like there's a coefficient and there's a like a real number in the denominator.
Mm-hmm.
Could you just toss that as the answer? Because like that's gonna be it after everything crosses out. I guess that.
Oh, yeah, this one.
that-
Yeah, this one here, the radius conversions would be 3.
Like you can see the 3 at the bottom and like that's.
That's
gonna be
fine. That's
bottom.
fine.
So
Yeah, yeah.
I doubt there's gonna be a question that's that easy, just what's the radius?
It's possible,
to use?
but, those types of problems have shown up on the AP exam too, just asking for the radius. Just see if students understand that it's asking about that R value instead of something else, so.
If we have a plug in chug one, is there any strategy to that, or is it just really just you just keep guessing numbers until you find the right one?
Yeah, keep guessing numbers. Yeah. And those will only be from the, in a calculator portion of the test.
This is all calculated.
It's all calculated.
The two, like, for on the normal air round, like alternating student air round, one aspect air round is just asking for A and N plus.
That's right.
And then for the Grange, that's just like the F max stuff.
That's right. Yeah, that's if you have a series that is not alternating series. And so you have to go through that additional test to the printer.
So on test, how strict are you gonna be with like formatting? It's like if I don't write R of X or like R N of X and stuff,
That's fine.
that's fine. And then for the Grange, when it says F of max, it's just saying when you calculate F of 5 or like whatever the F is, it's just asking what is the max value of that function in the interval.
In the interval, right? So sometimes you gotta test the endpoints to see which one is a larger value.
So it's like sine.
Other times, whether if it's signed, then you just can negative 1 and 1. But then sometimes the definition is given to you explicitly. You just follow that definition and just get that max out.
And then for the something from the quiz, is it like you gonna ask this questions that you would have asked in the quiz? Is it gonna be like limit, not limit, integral, stuff like that?
It's going to be, yeah, it could be like asking like a limit comparison problem or a GST or P series or interval test.
How many of those are
Just 2 at the most.
2 at the most?
Yeah.
Thank you.
I just have like questions that don't require the paper. So like with you said, like with the formatting stuff, we don't need to put like R.
R sub index, no.
Don't need to say that. I'm assuming if it's ratio, we do need to say that this n approaches infinity.
Yeah.
Okay. We need the label that it's IOC, or can we just write out like 0 is less than X plus?
That's fine. Easy to write out.
I just format. Yeah.
Mhm.
It's nice. Remember what it was. Oh yeah, for the maxes. So if we see like a sine or a cosine, since like we should just automatically assume that they're 1, or do we just,
Wait, say it again?
if it's like asking for the max of something, the functions like and the it's like sine, we just
Mhm.
assume that it's 1, like we just go straight to 1.
Yeah,
Okay.
yeah. If sine is by itself, but if sine is in the exponent of something, then I would test it more
But
carefully.
if it's just like a sine, it's like 3 sine of 2x. Well, if it's 3 sine of 2x, it's like the input.
Oh, well, it'd be 3. That 3 will push it out between negative 3 and 3. Because 3 is the amplitude. The 2x is just going to make it stretch horizontally.
So if there's a coefficient,
That's going to be your amplitude.
then that's what the max is.
Mhm.
But if there is none, if it's like
Just-
sine of 2x squared, it's still just 1.
There's still 1.
Okay. And then if it's any other function, like with the e, you just plug in whatever the x is. That's just what. Do we have to like change that into decimal, or when we like write out like our answer, it's like e squared over like 5 factorial times like, I don't know, like 0.8 minus 0 to the 5th. And then do we just say equals, or do we want us to convert e squared into a decimal and 5 factorial into another number?
Yeah, I think it's, if you can show me that work and show me the decimal, that would be
Okay,
great.
so I'd go from e squared to like this,
9 something
9
or
something.
8 something.
So like 8 or 9 over 5 factorial, which is like 120, and if it was 0.8 minus 0, then 0.8 to the fifth, and then we just say like equals.
Yeah.
And then we can
Decimal calculator, yeah.
just around to the third decimal.
30 decimal places, yeah.
Alright, thank you, Mr. Long.
Okay, yeah. See you in class.
See you in third period.
Yeah.